Introduction to Maritime Safety.
Good day everyone, I am Teacher Francis and I will be your teacher for the whole semester. Welcome to the first quarter of our Introduction to Maritime Safety class. Our first lesson is all about determining the means of survival at sea in the event of abandonment. At the end of the lesson, you are expected to identify emergency situations, use of life-saving appliances, and lastly, describe the use of survival crafts during ship abandonment.
Topics. Lesson 1. Determine the means of survival at sea in the event of ship abandonment, DMSS. LO1. Types of emergency situations. LO2. Types and usages of some life-saving appliances. A. Life buoy. B. Life jacket. C. Immersion suits. D. Thermal protective aids. LO3. Use of survival crafts. A. Lifeboat. B. Rescue boat. C. Life craft. Topics. Key terms. Bailers. Buoy. Bilging. Drowning. Hook. Inflatable. Lanyard. Life buoy. Paddles. SOPEP. General objectives. What you will learn. In this chapter you will identify the emergency situations. Identify the use of life-saving appliances. Describe the use of survival crafts during ship abandonment. Skills you will use. In this chapter you will. The students will learn how to use the life-saving appliances. LO1. Types of emergency situations. An emergency situation on ship must be handled with confidence and calmness, for hasty decisions and jumping to conclusions can make the matters even worse. It has been seen that in spite of adequate training, people get panic attacks and eventually do not do what they should in an emergency situation. As far as the seafarers is concerned, first and foremost, he or she must be aware of the different types of emergency situations that can arise on board ships. A. General emergency situation on board. Fire. Man overboard. Abandoned ship. Engineer's call. CO2 alarm. Engine room flooding. Cargo hold flooding. Pollution prevention. B. Different emergency situations. Emergency situation guide. Officers and crew should familiarize themselves thoroughly with the fire training manual and the training manual on life-saving appliances of the ship. General alarm. In case of general alarm, rush to muster station with life jacket, immersion suit, and act according to the vessel's muster lists. Act as per the emergency explained by the in-charge officer. Fire alarm. In case of a fire alarm, inform officer on watch. Check if it is a false or true alarm. Report back of findings. In case of fire, raise the fire, general alarm as soon as possible. Try to stop fire, and if it is not possible, muster according to the fire muster list. Man overboard signal. In case of man overboard signal, rush to the deck and try to locate the crew member fallen in the water. Throw life buoy and inform deck. Abandoned ship signal. In case of abandoned ship signal, rush to the muster station. Carry as much ration, water, and warm clothing as you can carry. Act according to the vessel's muster list. Engineer's call. In case of engineer's call, all ship engineers should assemble in the engine control room. CO2 alarm. In case of CO2 alarm, leave the engine room immediately. Engine room flooding. In case of emergency room flooding, chief engineer should be called immediately and general alarm should be raised. Immediate action should be taken in preventing more seawater to enter the engine room, and emergency bilging from the engine room should be established in accordance with the chief engineer. Cargo hold flooding. In case of cargo hold flooding, master must be informed immediately. All precaution must be taken to contain the flooding to that hold. General alarm must be raised. Pollution prevention. In case of any oil spill, pollution, immediate action should be taken according to the vessel's shipboard oil pollution prevention plan. Emergency plan SOPEP and onboard SOPEP equipment located in deck stores should be used in case of oil spill. In case of other emergency situations, call for help either by using the phone or by activating the emergency call. Whatever might be the situation, keep the master, chief engineer and officer on watch informed of the situation of all the time.
Each crew member on board has a special duty during emergencies. On the emergency plan, you will find information about your shipboard organization during fire, the special duties for each crew member, and general fire instruction. The shipboard organization on board are on most ships organized as follows. The shipboard organization vary from ship to ship, so it is important that you become familiar with the organization on board your vessel and that you know your duties during emergencies. Click on the different titles in the organization chart and look at an example of the assignment for each squad. The master is in overall command and keeps in contact with all squads. The junior officer and the helmsman muster on bridge when the fire alarm sounds. The junior officer relieves the duty officer and operates GMDSS radio as per the master's instruction. The chief officer is in charge of the operation if the fire is on deck or in the accommodation. The chief officer reports to the master as soon as he arrives on the scene. The chief engineer is in charge of the operation if the fire is in the machinery space. The chief engineer reports to the master as soon as he arrives on the scene. He is also in charge of releasing CO2 or halon on orders from the master. Muster at their muster station as instructed. Collect relevant equipment and put on gear as required for the particular emergency. Report to bridge when ready. When ordered, place necessary equipment close to the emergency site. Muster at their muster station as instructed. Collect relevant equipment and put on gear as required for the particular emergency. Report to bridge when ready. When ordered, place necessary equipment close to the emergency site. Muster in the engine control room. If not accessible, meet at the fire control station. Report to bridge when ready. Start fire pumps or other machinery as requested. At the sound of the halon alarm or CO2, leave the engine room at once and report to the person in charge. Muster at their muster station as instructed. Report to bridge when ready. If required or ordered, stop requested ventilation and close fire flaps. Isolate electrical equipment. Operate fire emergency technical appliances. Start emergency fire pump. Muster at the ship's hospital. Report to bridge when ready. As ordered, collect stretcher and first aid kit and proceed to the place of incident. Transport respiration. Search cabins if anybody missing. Constant vigilance or watchfulness is important on board ships and on offshore installations. All crew should be aware of the risk of fire, proper behavior on board, and every individual's responsibility. Even though ships are constructed to be as safe as possible, there is still the risk that accidents may occur. This is because many ships carry oil, gas, or chemicals on board. In addition, a great deal of dangerous work such as welding, burning, and grinding take place on board. It is therefore important to follow procedures for dangerous work such as hot work and cold work, fire watch, fire rounds on board. Click on the buttons to learn more. Hot work is any work involving welding or burning, and other work such as grinding and electrical. Hot work outside the engine room workshop should be prohibited until safety considerations have been met and hot work permits have been issued. When hot work is performed, Remember to check the surrounding area for combustible gases. Always have a fire extinguisher close by. Always have a fire watch posted. There should always be a person on fire watch when hot work is being performed. The designated fire watch should never have any other duties than being a fire watch. It is essential that all crew on board have the right attitude towards the prevention of fire. The company should therefore ensure that safety awareness is an important factor in their quality management. All crew should be aware of irregularities, report irregularities, follow instructions, orders and company procedures, have a good understanding of the contingency plan, keep the workplace clear and tidy. You are responsible for your own safety. It is therefore of vital importance that you know your duties when accidents occur and that you show safety consciousness. Safety is, among other factors, well-planned work operations, trained co-workers, training and drills, good working environment, good working methods and procedures, correct use of tools. What shall you do if you detect a fire? Please read the general fire instructions below. Activate alarm signal on detection of fires, no matter how small the fire seems to be. Try to extinguish a starting fire with extinguishers, blankets, etc. If it's not possible to put out the fire during its first few minutes, close all ventilation to prevent air reaching the place of fire. Do not open doors or hatches from areas where smoke is not seen to be coming out, unless wearing fire protection equipment and carrying fire extinguishing equipment. Keep in mind that a smouldering fire may produce invisible toxic gas. On alarm, it is important that everybody musters as quickly as possible in order to see if anybody is missing. Report immediately if any person is missing. If the ship is in port, call the local fire authority immediately. It is the duty of every member of the ship's personnel to be familiar with the location of all equipment, hand extinguishers, hoses, and emergency exits.
Man overboard is an extremely serious and potentially fatal event that every CRV crew could experience at least once in their career. A well-trained skipper and crew have a far greater chance of succeeding at recovering the person alive. The immediate response taken by the crew member witnessing a man overboard or realizing that a crew member is missing, shout "Man overboard." This will alert all crew to the emergency situation. Deploy a Dan buoy, life ring or similar to provide a floating datum. It does not matter if the person is visible at this time or not. The person in the water may see the flotation device and be able to get to it, if not it serves as a reference point for maneuvering the boat back to the man overboard. CRV crew wear life jackets at all times while underway, so the primary function of any equipment thrown in a man overboard situation is not necessarily additional flotation, but as a reference day or night. The equipment thrown should be highly visible, have a light attached, be able to be deployed quickly, be affected as little as possible by the wind. The same equipment would be suitable for use as a floating datum in any subsequent search. The crew member who shouted the alert now points continuously with outstretched arm at the man overboard, if still visible, or Dan buoy, ensuring that visual contact is maintained. This will also indicate the man overboard's location to the skipper. It is imperative that this crew member does this and nothing else until relieved from this duty by the skipper. The secondary actions. In large vessels, a common practice is for the initial turn to be made towards the side which the man overboard fell from, to reduce the chances of the vessel's propellers striking the man overboard. The size of most CRVs means that the crew member on the helm is unlikely to respond quickly enough for this to be relevant. Given a reaction time of 3 seconds from the person falling overboard to the helm being put over, at 6 knots the vessel will have traveled 9 meters. At 12 knots the vessel will have traveled 18 meters. Initiating an immediate turn to avoid propeller strike is not only irrelevant for most CRVs, but a potential hazard, risking injury to other crew or even a second man overboard. There are different methods that can be employed to turn the CRV back towards the man overboard. Regardless of which method is employed, one thing that the crew member on the helm must be able to establish is the reciprocal course. The reciprocal of any course is found by adding or subtracting 180 degrees. For courses less than 180 degrees, add 180 degrees. For courses more than 180 degrees, subtract 180 degrees. For example, course 50 degrees reciprocal is 230 degrees. Course 315 degrees reciprocal is 135 degrees. The design of many marine compasses allows the helmsman to see the course the vessel is on, and the reciprocal at the same time. Another useful aid is a reciprocal table displayed by the helm position. Methods for turning. This module describes 3 commonly used methods that can be used to turn a vessel back towards a man overboard. Williamson turn. Simple turn. Stop, slow and turn. The Williamson turn was developed primarily for large vessels, whose turning circle was such that the man overboard would almost certainly be out of sight by the time the vessel had turned around. The size of the turning circle also meant that merely turning 180 might put the vessel on a reciprocal course, but it would be nowhere near its reciprocal water track. To execute a Williamson turn, the same speed is maintained throughout the maneuver until the vessel is on its reciprocal course. Vessel is first turned until the heading is approximately 60 degrees to 70 degrees from the original course. The helm is then reversed with the same amount of helm applied the opposite way as was used in the initial turn, for example 1 full turn of the wheel to starboard, then back to midships, and 1 full turn of the wheel to port, until the vessel is on the reciprocal of the original course. The vessel turns and initially describes 1/4 of a circle. When the helm is reversed, it then describes 3/4 of an identical sized circle. What needs to be known for this method to be fully effective is at what point on the initial turn is the helm reversed. This can only be established through practice and training. An alternative method is, maintain or reduce speed. Turn the vessel around. Use the still visible floating datum to turn onto the reciprocal water track. While simpler than a Williamson turn, this method depends heavily on the wake hand, or floating datum being visible. Both may be rapidly lost from sight in bad weather, especially at night or in poor visibility. The size of the turning circle will determine at which point the vessel returns to cross its original water track. With a large turning circle, there is a small, but potential risk of running over the floating datum or even man overboard if reference to either is lost during the turn. The need to keep a visual reference on the floating datum or wake means that this method needs a relatively small turning circle to be effective. Unlike the previous 2 methods, the first step is to slow down to a near or full stop, then turn short around. Motor ahead on the reciprocal course. The maneuverability of most CRVs means they can be turned in little more than a boat length. As the vessel was slowed down without altering course, the wake will be clearly visible off the stern. Lining up the center of the residual wake and the floating datum means there isn't a need to calculate reciprocal heading. Whatever method is used in a man overboard situation, the helmsman must alert the other crew members prior to any maneuver. Any maneuver should be preceded by a loud and clear warning from the helmsman. For example, turning starboard, followed by a pause of 1 to 2 seconds before initiating the maneuver. This is a practice which should be a standard operating procedure at all times, not just in a man overboard. The mob function on the CRV's GPS should be activated at the first opportunity. This will provide a backup to the floating datum, and automatically displays bearing and distance to the man overboard waypoint. Sending out a distress call will ensure that assistance will be available if it becomes necessary. It can always be cancelled should the situation be resolved. Whether the distress call is sent immediately or at a later stage is at the discretion of the skipper. The average CRV carries 4 crew as its normal complement, and in the event of a man overboard there will be 2 crew needed to help in the recovery of the man overboard, and 1 on the helm. While turning around, sighting the man overboard, then preparing to approach and recover, sending a distress call may be an unwarranted distraction. In the event of an unwitnessed man overboard, or where the CRV fails to locate the man overboard, a then distress call must be made. If the man overboard is lost from sight, a structured search must be initiated. Being unable to locate a fellow crew member will be highly stressful for all aboard. For the search to be successful, correct procedures must be followed. Having sighted the man overboard and assessed the situation, the skipper or crew in charge, skippers are not immune to falling overboard, will allocate positions to the crew and brief them on appropriate recovery actions. The following points must be considered after rescuing the man overboard: cancel any distress call. Continue to monitor the patient's condition, ABCs, and treat for shock as required. Complete the necessary unit and Maritime and Z forms as required for a man overboard incident.
When it comes to survival at sea, there is nothing more important or comforting than being properly prepared. Understanding the dangers that can overcome you and your vessel while at sea is a crucial part of surviving. On the other hand, you need to carry out drills so you can react quickly and without thinking in an emergency situation. The most practiced drills are man overboard, abandon ship, and fire drills. It is all about the life of yours and the people under your responsibility. So, be safe.
SOLAS regulation requires that every crew member shall participate in at least one abandoned ship drill and one fire drill every month. It is widely known. However, there are certain variations on the launching and operating frequencies depending on the type of yacht's equipment. Our idea is to bring some extra light on the subject of abandoned ship drills. It is the very first question to ask, after asking, why do they have to be carried out? The answer is easy. Because abandoned ship is not something that happens to a crew on a daily basis. Nevertheless, in the open sea, there is no emergency service to come and save our lives. So, the crew has to know what to do and how to do it, and to communicate efficiently and work as a team in case of an emergency. What shall the abandoned ship drill actually include? Summoning of passengers and crew to their muster stations, with the alarm ensuring that they are made aware of the order to abandon ship.
Attention all, this is abandoned yacht drill. All crew and guests go to muster station. I repeat, all crew and guests go to muster station. Over.
Reporting to stations and preparing for the duties described in the muster list. A mock search and rescue of crew and passengers trapped in their staterooms.
Anyone here? Anyone here? All guests must go to muster station. Anyone here? Anyone here?
Launching of life raft after any necessary preparation. Instruction in the use of radio life-saving appliances, SART and EPIRB. Checking that passengers and crew are suitably dressed. Checking that life jackets are correctly donned. Checking that immersion suits are correctly donned. Emergency lighting for mustering and abandonment shall be tested at each abandoned ship drill. To evaluate the safety precautions and topics for overall operation of disembarking of yacht and embarking of the life raft. Each survival craft should be stowed in a state of continuous readiness so that 2 crew members can carry out preparations for embarking and launching in less than 5 minutes. Remember, a drill can be paused so that any difficult elements can be explained. The crew's experience is important in determining how quickly a drill or certain elements of a drill can be carried out. It is important that drills are carried out in a safe manner, and therefore, any elements that may involve unnecessary risk will require special attention or should be removed from the drill.
All this and training activities have to be duly recorded in the official logbook. Also, details of drills shall be filled in company's safety management system. Hopefully, this video provides you a wide scope of drills trainings and launchings that have to be carried out with survival crafts on board. We, as Türk PNI and Zone Spiyat Management, are with you all the time to keep you trained, to improve your skills and fully secured under a legal protection. Keep watching us, to be your master.
Something very important, that is actions to be taken during engine room flooding. Your responsibilities or duties will differ whether you are chief engineer or management level officer or an operational level. Let's talk what we have to do on if you're an operational level officer. So as you see, the engine room is getting flooded. Our prime aim should be that the water should not touch the main engine flywheel, or it should not touch the main generators. It is for this reason, clearly note that it is for this reason the main generators are not placed on the bottom platform, and it is placed one or two platforms above the main engine bottom platform. So if you see engine room is getting flooded, first action what you have to do is activate the general emergency alarm. If you cannot find the general emergency alarm in the bottom platform, just raise the fire alarm. Or if you have a public address system, just announce it. Or if you have the facility to call the bridge from bottom platform, pick up the phone and then inform bridge, and then let bridge inform everybody, make an announcement. Once the alarm is raised, your action must be immediately to start the bilge pump and put it in the bilge holding tank as much as possible. And next is to start the oily water separator, provided you have the authority to do so. If you're a first engineer or second engineer, you can do that, and if you're a fourth engineer, wait for the instructions to start the oily water separator. Now again, what you have to do is you can probably try to wait for the chief engineer's instructions. So then in the meantime, you can go and identify the water ingress source. Usually if it's going to be engine room flooding, you can't near, or you cannot really go and search for the exact location of the water ingress, because the water is going to really gush in at high force. So as a watchkeeping engineer, rush to control room, start additional generators, because you're going to start as many pumps as possible, or you're going to slow down the main engine, we don't know. So start the additional generator, and depending upon the source of water ingress, try to stop the ship. You can ask the bridge to stop, or if you can take the controls to ECR, ask the chief engineer and bring down the fuel, leave it to zero, that's all. So once the ship is stopped, the chief officer usually takes the decision to adjust the trim and list as required, inform DPA and other authorities if the vessel is in port or near the coastal waters. That master will take care of. Your prime aim should be to concentrate on the bilge pumps and transfer all the possible bilges to bilge holding tank, primary bilge tank, or any other waste collection tank. Run the OWS, enter an engine room logbook. After which, here are some more sequences. If the flooding happens in port, inform chief engineer and duty officer on bridge, and usually in case of tankers, the cargo control room, and raise the general emergency alarm. Now main point is to start the additional generator. After getting approval or with the presence of chief engineer, definitely he will not allow you to open the emergency bilge section, because he himself will open that valve and try to pump out the bilges. Try to locate and isolate the leakage, and whatever chief engineer orders, just try to follow it. If the vessel is at sea, open the emergency bilge section valve after chief engineer's permission or master's permission. So it is for this reason we have to keep the emergency bilge section valve in good working order, weekly grease it and free up the handle so that in case of emergency you can open it. one main aspect is you should have a big F key or F lever to open the valve. You need not go and search it so that in case of emergency to open the valve you don't get it, and stop the main engines as required. Generators must be running to give sufficient power for the ballast pumps or main seawater pumps as required. So that's going to be your engine room flooding response.
This is an example of the damage an oil spill can cause. This table shows the quantity of crude oil in millions of tons that are transported at sea. This quantity increases each year. This table shows the quantity of oil spilled. As you can see, the amount of oil spilled has decreased rapidly the last years. The two previous pages show that even though the quantity of oil transported at sea is increasing, the amount of oil spilled is decreasing. The main reasons for this are implementation of MARPOL, the International Convention for the Prevention of Pollution from Ships, companies' awareness and understanding of the importance of pollution prevention, better follow-up from flag state and other authorities. In the USA, the accidents involving the Exxon Valdez and Megaborg were in focus and were well covered by the media and press. This influenced public opinion. The result was the establishing of the Oil Pollution Act of 1990, OPA 90. The media showed pictures of the rich animal life and the magnificent coastline in Alaska covered with oil and the suffering of dying seals and seabirds. This presentation made a strong impression, which forced the US Congress to realize that the existing international conventions had to be reviewed and improved in order to protect and take care of American interests. American lawyers developed the Oil Pollution Act, and the Congress supported the proposed act. The main stipulations in OPA 90 are the threat of unlimited responsibility, demands for double hulls, direct access to the means in P&I companies in case of indemnity due to accidents, higher graded demands meant for the crew regarding narcotics and alcohol testing, use of pilots in sensitive waters. Upon entering American waters, OPA requires drill training according to OPA 90 regulations. The drill training should be logged and reported according to the ship owner or operator's policy. OPA 90 regulations are in force for all types of ships. The International Convention for the Prevention of Pollution from Ships, 1973, modified in 1978, is better known as MARPOL 7378. This convention is one of the most important international agreements on the subject of marine pollution. These regulations are made for the preservation of human environments in general and the marine environment in particular. The goal is to achieve the complete elimination of international pollution of the marine environment by oil and other harmful substances, and the minimization of accidental discharge of such substances. Detailed regulations covering the various sources of ship-generated pollution are contained in 6 annexes. Annex 1, Regulation for the Prevention of Pollution by Oil. Annex 2, Regulation for the Control of Pollution by Noxious Liquid Substances in Bulk. Annex 3, Regulation for the Prevention of Pollution by Harmful Substances in Packaged Form. Annex 4, Regulation for the Prevention of Pollution by Sewage from Ships. Annex 5, Regulation for the Prevention of Pollution by Garbage from Ships. Annex 6, Regulation for the Prevention of Air Pollution from Ships. Annex 1 of MARPOL 7378, Regulation for the Prevention of Pollution by Oil. Chapter 1. Generally, it covers subjects such as surveys and inspection, the form and duration of certificate. Chapter 2. Requirements for control of operational pollution covers subjects such as segregated ballast tanks, crude oil washing, the oil discharge monitor, the oil record book, retention of oil on board. Chapter 3. Requirements for minimizing oil pollution from oil tankers due to side and bottom damage. Covers subjects such as damage assumptions, subdivision and stability. Chapter 4. Prevention of pollution arising from an oil pollution incident. Covers subjects such as the Shipboard Oil Pollution Emergency Plan. Annex 2 of MARPL 7378. Regulation for the control of pollution by noxious liquid substances in bulk. Annex 2 covers subjects such as the categorization and listing of noxious liquid substances, discharge of noxious liquid substances, pumping, piping and unloading arrangements, the cargo record book, survey and certification of chemical tankers, requirements for minimizing accidental pollution. Annex 3. Regulation for the prevention of pollution by harmful substances in packaged form. Annex 3 covers subjects such as packing, labeling, documentation, stowage, quantity limitations. Annex 4. Regulation for the prevention of pollution by sewage from ships. Annex 4 includes such items as surveys, the form and duration of certificate, discharge of sewage, standard discharge connection. Annex 5. Regulation for the prevention of pollution by garbage from ships. Annex 5 includes such items as the disposal of garbage outside special areas, special requirements for the disposal of garbage, the disposal of garbage within special areas, port state control on operational requirements. Annex 6. Regulation for the prevention of air pollution from ships. Included are guidelines for the emission of different substances, as well as specific requirements for testing, surveying and certification and fuel quality.